point it apart and I'll tell you what it's about. Because old prospecting dudes, yeehaw, would actually look at their horses and drinking in the pond, and they realized that it looked a lot like that. So it was essentially drinking up the oil. There's the clamp and carry bar, which holds onto your polished rod. So your clamp and carry bar are actually attached to the horse's head. Those parts will go and attach to the polished rod. Stuffing box helps prevent gases that should not be in our atmosphere from coming up. It also helps prevent leakage of oil. So when we're pulling up the oil, we don't want to just go, all over the place. So what we do is we put a stuffing box, and that helps it from going up through the wrong tubing and go straight to the regular, where we want it to go. Okay, so the flow line is the main part where the oil actually pushes through. So yes, things are flowing through it. The flow line is the line that attaches to everything else that allows the oil to go from the well and go out to the tubing that leads it to production areas and refineries, and where things like our vac trucks will pull them out and transfer them other places. So they actually have a major pump. When I worked in the oil fields, I actually was a safety guy for the guys that would actually drive out to those pumps. I mean, we have our own version of Deal or No Deal. It's more like, did it break or didn't it break? The casing protects your tubing. So the casing is almost like an outer shell. Not only that, but it also helps when you have your tubing, which I am assuming you're going to talk about next. The tubing will actually pull up the oil. The casing will give space for gas to release, so that way the oil and the gases are separate as much as we possibly can. Not only that, it protects the tubing from any damage. So hopefully, if something does happen, if something does crack, the casing will crack before the tubing. The casings are there to help prevent if an earthquake does happen. Our pump jacks and our well heads and things like that are built in a way to where they think about that. They think about the controversial things like earthquakes. Because obviously a lot of people have come to our companies, especially environmentalists, and said, well, what if an earthquake happens? There's going to be a lot of oil everywhere.
Right.
So we have put in technologies that will help to where if an earthquake does happen, everything shifts instead of just one or two parts. Obviously, if we have a major earthquake like an 8.7 or something, it might not matter. Smaller earthquakes, we can prevent those. Sure. It is a form of anchor, like ships use in sea to stop the ship. Yeah. The tubing anchor stops the tubing from moving around when we don't need it to. So when that tubing anchor is there, we don't want soft soil to be adjusting and then the tubing to move 2 centimeters or 2 inches, and near the bottom still be 2 inches the other way at the top, causing the tubing. There's sinker bars. So those bars go down and they'll hold certain components down, aka sinking back to the earth. So we actually have certain parts in there that need to go back down. So the horse's head and everything will push those parts down. However, we need something to help that near the end so it's not so stressful on the horse's head. The pump will do exactly that. It'll pump fluids through. So it'll help when the horse's head is coming up to pull oil up, it will help that oil go up more easily. Once again, trying to put less stress on our automation. So almost like the sea, pretend the oil is the sea. Gas is in that oil. So that will help us try to anchor out the gases from the oil. We cool it off. So it going through the smaller tubings is helping it cool off. That's why we use metal tubings, because it sucks some of that heat away. The closer you get to the Earth's center, the hotter everything gets. Oil can be in a range of areas in the Earth's crust. So sometimes we'll go 2,000 feet down. Sometimes we'll go really, really, really far down until it gets too hot. So oil companies came up with that once they found out that one single speed all the time does not work. The reason being is if you have a pump jack that's going and there's no more oil in the hole, and that's actually what we call it. It's called the hole. When there's no more oil down there, when the pump jack's going one speed and there's no more oil down in the hole, what will happen is everything will start to grind. The oil that was down there doesn't just come out, it lubricates everything that's in the ground, making it run smoother. So we put automations on these, further automations other than just, going one speed. So when an oil well is running low, the pump jack will go slower. So that way, if I'm walking through the field, I can tell you, oh, that one's going really, really fast. It has a lot of oil in that hole. Might be newer. That one is going very slow. It might not have that much oil in there. That one's off. There's not enough oil in that hole to keep it lubricated and have it safely being pulled up. Because if you pull all the oil out of a hole, the hole can collapse, causing a crevice in the earth and potentially harming people. And we don't want that. Probably the most chemically hazardous is called H2S, hydrogen sulfide. H2S, we measure in things called ppm, parts per million. Literally, parts per million. How many millions of parts do we have?
How many is a million? These are the questions.
1, 2, 3. No, I'm not
We don't
counting
have
all the way
time
up there.
for this.
No. So H2S, what happens with H2S is it's a gas that you can work in, but only if you're under certain parts per million. New California state laws, or OSHA, or as we call it in the oil fields, Cal OSHA, basically California OSHA, is written in such a way that we have to wear monitors in what we call the breathing zone. So to the top of your head in a circle. So your mouth is the center of the circle. The top of your head is the top of the circle. And you go a direct circle, and that's your breathing zone. Anywhere within that circle, your H2S monitor has to be. The reason being is it gives you an accurate measurement of how much H2S is actually going to you. H2S likes to sit at the bottom. So if it is tall enough to reach your breathing zone, it's kind of dangerous. It's kind of like that pound cake I made the other day. Real dense.
Right.
Right. 2 seconds into recording and Ryan burped.
I love it. Okay.
Blooper reel.
So, family.
Yes, family.
Shall we officially go on the record?
Yeah. Let's do it.
So, as promised, I have here with me a certain person who at one point may or may not have actually worked in the oil field.
What happens with H2S is at a certain parts per million, it's safe to breathe in for short amounts of time. So at 5 parts per million, you can work a full 8-hour day. At 10 parts per million, you can only work a 4-hour day. At 20 parts per million, everybody has to get out of the fields. The reason being is at 20 parts per million, within less than 2 hours, you can start feeling nauseous, throw up, have headaches, feel like, oh, that would be horrible. Most of our guys can't drink for up to 3 days after being exposed to H2S. It'll actually cause you to regurgitate everything you've had within the last 24 hours.
So here we have a little demonstration of what it's like to wear. Is this fire resistant or
This
not?
is non-fire
So
resistant
this is
clothing.
not fire resistant clothing. We'll see how that does.
I made it caught fire.
You literally almost got on fire.
I almost got on fire.
Oh my!
Do not
goodness.
try this at home, everybody.
Yeah. We should probably put that at the beginning. Never, ever, 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 under any circumstances whatsoever. I don't care if your house is on fire. Don't even do this. Don't ever, ever do this. Thank you, please, and pretty please.
So yes, automatically you saw that it caught on fire. It almost went in my hand. This is what we call fire retardant, aka resistant to fire. When I say resistant, I do not say immune. So eventually, in a long period of time, you can actually get hurt with this on. But
But you see how it's not catching fire.
1, it doesn't catch fire. 2, the person inside, if I hand this to Ryan, the clothing itself will be a little bit warm. But see how it has almost no damage on it.
That's amazing, folks. And for only $19.99, you can get your own fire
I
resistant.
could probably
jacket.
actually leave that in there for a second too.
So this is exactly the kind of thing that people working in the oil fields need to wear. Because as we know, oil, gas, or anything of the like is flammable. Flammable meaning at any single moment in time it can catch on fire. And you don't want to be like the oil. You want to not be like the oil and not catch on fire. So
I'm actually trying to burn it now. But you see,
It's
actually,
smoking.
it caught fire that moment, and then it automatically went out.
see, it's smoking, but it doesn't actually quite catch.
And the reason being, the fibers put into these clothing will actually. Oh, it smells horrible.
It does actually.
Sorry, that's retarded. Those are actually. Well, me and Ryan are smelling are the chemicals that is put into the fire retardant clothing to make it fire retardant.
Cool.
Basically, fire retardant clothing are 100% cotton mixed with other chemicals that will prevent it. So those chemicals snuff the fire. So basically, it's like if you take a candle and you blow it out, that's basically what those chemicals are doing.
Unless it's one of those like trick birthday candles that never go out.
And that's what those chemicals do. They're there for safety.
Right. So to reiterate again, don't set yourself on fire, and certainly don't have a campfire without your parents' permission.
My mom said no, but I did it anyways.